Hello everyone, welcome back to my YouTube channel. I'm a student of Sri Venkateshwara College of Engineering from the Department of Computer Science and Engineering. So today I'll be presenting a topic called Test of Significance for Large Samples from the subject Mathematics for CSE stream. So let's begin with the topic Test of Significance for Large Samples. So understanding and properly conducting statistical test of significance is a crucial skill for data analytics researchers and anyone working in large data sets. So in this presentation, we will explore the fundamentals of hypothesis testing for large samples, including the key concepts, assumptions, and interpretation of results. By the end, you will have a solid grasp of how to apply these techniques to draw meaningful insights from your data. So next we have introduction to hypothesis testing. So what is hypothesis testing? It is a statistical method used to determine whether a particular claim or hypothesis about a population parameter is supported by the sample data or not. Why do we use hypothesis testing? So it allows researchers to make data-driven decisions, evaluate the effectiveness of interventions, and draw reliable conclusions from their findings. Key steps in hypothesis testing: state the null and alternative hypothesis, determine the appropriate test statistic, calculate the p-value, and make a decision based on the p-value. Null and alternative hypothesis. So null hypothesis, it represents status or the claim that is there no significant difference or effect. It is a hypothesis that the researcher aims to disprove. Next we have, it is also denoted by HO, and alternative hypothesis H1. It represents a claim that the researcher believes to be true, and it is the hypothesis that the researcher aims to provide evidence for enough through the statistical test. Example: HO, the mean income of population is $50,000, and H1, the mean income of population is not $50,000. Next we have type 1 and type 2 errors. So type 1 error, it occurs when the null hypothesis is true but it is incorrectly rejected. This is also known as false positive result. Whereas type 2, we have when the null hypothesis is false but it is incorrectly accepted. This is also known as false negative result. Controlling error rates. So researchers can adjust the significance level alpha, which is denoted by alpha, to balance the risk of type 1 and type 2 errors depending on the context and the sequences of each type of error. Next we have importance of understanding errors. So recognizing and minimizing the risk of both types of errors is crucial for drawing valid conclusions from the statistical test. So coming to the next topic, we have test static and sampling distribution. So under this we have three types. Test static. The test static is a numeric value calculated from the sample data that is used to determine whether to reject or to reject the null hypothesis. Sampling distribution. The sampling distribution represents the probability distribution of the test static under assumption that the null hypothesis is true. Next we have critical values. So it defines the boundaries or the acceptance and rejection regions for test static based on chosen significance level. So we have a graph which depicts test static, sampling distribution, and critical value. So next we have Z10 Z test for means. So what is Z test? It means it is used to determine whether the mean of population is significantly different from a hypothesized value when the population standard deviation is known. Next we have test static. So test static for Z value means it is calculated as Z is equals to a sample mean minus hypothesized mean by population standard deviation by sample size. Next, assumptions. So here for Z test for means, what are the assumptions we make? The sample is randomly selected from the population and the population standard deviation is known, and the sample size is larger, which is n greater than 30. So Z test for proportions. So sample proportions. The sample promotion is proportion is the proportion of successes in the sample, and population proportion. The population proportion is the true population of the successes in the population. Test static. The test static for Z test for proportion is calculated as Z is equals to sample proportion minus hypothesized proportion by hypothesized proportion minus 1 by sample size. Assumption. The sample is randomly selected from the population. Sample size is larger, which is n into p greater than or equal to 5, and n into 1 minus p greater than or equal to 5. Next, we have the conditions for large sample test. First one is it should be sufficiently larger, which is greater than 30 for the test static to follow a normal distribution. Next, we have parameter estimates. The population parameter estimates mean population is used in test must be reliable and representative of the true population values. Independence. The observations in the sample must be independent of each other with no systematic patterns or correlations. Next, we have interpreting test results. So decision, reject the null hypothesis. Interpretation, the sample data provides strong evidence that the null hypothesis is false and the alternative hypothesis is likely true. Fail to reject the null hypothesis. So the sample data does not provide sufficient evidence to reject the null hypothesis, so the null hypothesis is likely true. So it is important to consider the practical significance of the results, not just the statistical significance. The p-value alone does not tell the whole story, and researchers should interpret the findings in the context of the research question and potential real-world implications. So conclusions and key takeaways. So the key concept which we covered in this PPT is hypothesis testing, null and alternative hypothesis testing, type 1 and type 2 errors. We spoke about all of these topics. Test static and sampling distribution, Z test for means and proportions, and interpreting test results. So importance of large sample test. So large sample tests are powerful tools for drawing reliable conclusions from data, as they leverage central limit theorem to make robust inference about population parameters. Next, the practical applications here in this topic is mastering these concepts and techniques will empower you to design and interpret statistical test effectively, leading you to more informed decision making and impactful insights. So this is it, guys. Please like, share and subscribe. Thank you.